Alright, go ahead and take a few moments to work on the warm-up. So try to decide which you'd rather have. Work for 30 days and earn $5 million, or work for 30 days and be paid 1 cent on the first day, 2 days on the second day, 4 cents on the third day, etc. Obviously keep doubling your money. So work on that for a little bit and we'll pause it, give you a little bit of time to think about it. We'll talk about the answer to the warm-up near the end of this lesson. Okay? So this is the homework from last night, arithmetic sequences, so go ahead and pull that out and start checking. So here are the first couple. And teacher will keep pausing as needed. Here are the next few. And the next one, I love this problem. Again, great application of an arithmetic sequence and context here. And the last page. Okay, today we're going to talk about geometric sequences. So it'll be a little bit different, but we're going to follow the same exact format that we did with arithmetic sequences. Same order of everything so that it makes sense. It worked real well yesterday. So I want you to be able to figure out the next few terms of a sequence, and I'd like you to be able to use explicit formulas for geometric sequences so that you can find any particular term and so that you can solve actual problems utilizing the structure of geometric sequences. Okay, the first thing is that a geometric sequence, the way you know that it's a geometric sequence, is that every time you're looking for the next term, you always have to multiply by something. You always multiply by a particular number. And whenever you multiply by a particular number, we call that number R. It's called a common ratio. Yesterday we talked about how we have to add or subtract something to get the next term. That was called a common difference. Now it's called a common ratio. And the way you figure out what that is, similar to yesterday where we took a term and then we subtracted the one right before it, well, now what we're going to do is we're going to take a particular term and we're going to divide by the one right before it. So when I do that, I get 108 divided by 324. That turns out to be 1/3, and that turns out to be my R. So that's what I'm looking for, is what is this R? And, similar to the D from yesterday. So you'll notice that each time we're multiplying by 1/3. Now you might say, well, aren't we dividing by 3? Yeah, that is the same thing, but we're going to want to multiply. So think about what you need to multiply to get the next number. So if I multiply 12 by 1/3, then that will give me 4. And then if I multiply 4 by 1/3, then that will give me 4/3. And if I multiply 4/3 by 1/3, then that will give me 4/9. And if I multiply 4/9 by 1/3, then that will give me 4/27. And again, the teacher can pause as needed if you need to think about that. But again, when you're multiplying by 1/3, you can tell that it's just affecting the denominator. The 1 on the top doesn't really, do anything to the 4. Okay? Alright, next one. State the common ratio. So again, to find the common ratio, you always just take one term, you always just take one term and then you divide by the one right before it. So this would be 1/2 divided by 1, which is just 1/2. I mean, if you do 1/2 divided by 1, of course it's just 1/2. So that's the R, it's the common ratio that we're looking for. So if we multiply this one, the 1/4, by 1/2, then that will give us 1/8. And if we multiply 1/8 by 1/2, that would give you 1/16. And then we're going to have 1/32, and then 1/64 to find the next four terms there. Alright. Now sometimes it's, that one may be obvious that the numbers are getting half as big, but maybe this next one's not as obvious. Well, good news. You can always just take this term and divide by the one right before it. And again, that pattern has to be the same for all of them. So you have to be able to do 18 divided by -6, get the same common ratio as you would if you take -6 divided by 2. So -6 divided by 2, the common ratio is -3. So that means we have to multiply it by -3. And if we do that, then we're going to get -54. We're going to multiply by -3 again. We're going to get 162. Multiply by -3 again. We're going to get -486. And multiply by -3 again, and we're going to get a positive 1,458. Now, I'm sure the teacher will have to pause a decent amount because I'm making this video pretty quickly this morning. Alright, now let's look at the actual formula like we did yesterday for an arithmetic. So this is the formula. Sorry about that. This is the formula. It's a sub n equals a sub 1 times the common ratio, and that's raised to the n minus 1. So make sure you see that little n minus 1 as an exponent. So a sub n is just considered the nth term, like yesterday. The r is called the common ratio, just like yesterday was the common difference. This is the common ratio, the thing you multiply by. A sub 1, again, is just the first term. And n is just your term number. Alrighty? So let's look at another problem. Okay, let's write a formula for this. So, just like yesterday, we're going to look to figure out what in the world is that common ratio. So let's look at it. So it looks like we take 1 and divide it by 3. So 1 divided by 3, that's it right there. That's your common ratio. So notice that if you take 1/3 divided by 1, that would also be the same ratio. 1/9 divided by 1/3, a little harder to see, but that would be the common ratio. Okay, so your first term you also need, so a sub 1 equals 3. So I go right to the formula. I'll write the formula again. A sub n equals a sub 1 parentheses r raised to the n minus 1. Okay, so now I start plugging in my numbers, the two numbers that I figured out here. So the first term is 3. The common ratio is 1/3, and then I'm raising it to the n minus 1. So that right there is the explicit formula for a geometric sequence. Alright, next one. A similar deal. So let's figure out what the common ratio is first. So it looks like we're just going to take the 32 divided by 8. So 32 divided by 8 is 4. That's the common ratio. Then we're going to need the first term, which is 8. And then we're going to go right to the formula. So a sub n equals the first term, which is 8, the common ratio, which is 4, and then we're going to raise it to the n minus 1. And that's it. Skip 4, I didn't like that one. And then go all the way to the practice, and I'll show you how we can find particular terms. So I'm looking at, so skip that, make a little note, skip that, and, oh, I have a application that I didn't print here, so let's take a look at this one. So Ice 10's sculpture is melting, so it loses 1/5 of its weight per hour. So I didn't have this one set up ahead of time. Alright, so it loses 1/5 of its weight per hour, so let's figure out what this one would be. So first, we have the first term. So it's starting off with how many pounds. It's a 1-ton ice sculpture, so that is 2,000 pounds. And then how much is it losing per hour? So that would be what we would keep multiplying by. So let's see if this works out. See, multiply by 1/5, so R equals. Now actually if it loses 1/5, that means so this is a little bit harder. So it loses 1/5, so that means that how much is left is actually going to be 4/5. So I'm not sure if you'll get that idea, but if you're losing 1/5, then it will work out well if we multiply by 4/5, and that's actually how much will be left after a certain number of hours. Well, so I'll kind of work it out here. So first I'll try to come up with the nth term. So the first term is 2,000. The R in this case would be 4/5, and then I'm going to raise it to the n minus 1. And so after 5 hours, I would have a sub 5, which would be 2,000, and then I've got 4/5 raised to the 5 minus 1, and I would plug that into the calculator. So that's going to be 2,000 times, and make sure you put 4/5 into the calculator, raise that to the 4th power, and it looks like we're going to have 819.2 pounds left over after 5 hours. Okay. There is a way to type the 4/5 into the calculator directly, or you can just do 4 divided by 5. But the way you use the calculator is there's a couple buttons with these nice calculators. You can press alpha, and then y equals, and then you can see it's the first option, and it has a little n/d, little numerator over denominator to actually type in the fraction. Okay, just a little tip if you want to do it easier with the calculator. Alright, so let's try maybe just one more here. So try to find a particular term. So look, we already had the explicit formula, so we're just looking to write a particular term. And actually, instead of doing this term, because they get too big, let's do just the 6th term. So 6th term, So let's go a sub 6, and we're just going to plug in a 6 wherever there's an n. So 6 minus 1, and so straight with the calculator. So it's going to be negative 2 times 1/4 raised to the 5th. So negative 2 times, and again that's 1 divided by 4 in parentheses, and then raised to the 5th power, which turns out to be negative 0.001, make sure I have the same thing here, 953, and actually let me use I didn't use my new operating system, so let me try to make that a fraction so it'll be better. 1 divided by 4 raised to the 5th. Oh yeah, that's better. So this is actually negative 1 over 512. So try that feature that I was telling you about, the alpha feature. Alright, so I think that's going to do it. Oh, no, I should probably go back to the warm-up. Let me go back to the warm-up. So, alright, so back to the warm-up. What would you rather have, $5 million or a penny a day doubled? So the first term is 1 penny. The r, we keep multiplying by 2, so the r is 2. So if we set up a little explicit formula for this, it would be 1 times 2 raised to the n minus 1. And what we're looking for is the 30th, so we can see how much money we'd have after 30 days. So that would be 1 times 2 raised to the 30 minus 1. So really all we have is 2 raised to the 29, which is 5, 3, 6, 8, 7, 0, 9, 1, 2. Now remember, this is cents, so we have to put in our decimal right there, and then we can put in our little commas, so we can tell that we have over $5 million, so we're going to definitely choose this option. Alright, good enough.